Okay, hello everyone. Welcome and thanks very much for joining us for today's webinar. I'm Jez Fredenberg and I'm based at the Tyndall Centre for Climate Change Research at the University of East Anglia in Norwich. I'm an agri-food journalist and I'm the Knowledge Exchange Fellow for the AFN Network Plus. And my colleagues from the network, Vicky and Neil, are also helping today and we'll be sharing useful links in the chat, so do look out for that. The AFN Network Plus is focused on the UK agri-food system and identifying and tackling the barriers to transitioning to a net zero UK by 2050. It's funded to the end of 2025 by UKRI, the umbrella body for the British Research Councils. So let's get on to today's topic. We know that our agri-food system needs to change to mitigate and adapt to many of the challenges it's facing. There are lots of different versions of what this change might look like, but what happens when we put net zero emissions in the driver's seat, meaning when reducing emissions becomes our main focus? What are the win-wins and trade-offs of this approach? So I'm very pleased that we have our speaker here, Dr. Pete Falloon, to dissect this for us. Pete is based at the Met Office and leads the organisation's climate service for Defra, providing scientific advice to support the department's decision-making on climate resilience and adaptation in the agri-food system. So he's the perfect person to help us with this topic. I'm sure you'll agree. I will hand over to Pete in a second to present, but if you've got any questions for him as we go along, please write them in the Q&A panel. And if you could just leave the chat function for discussion and sharing links so we can find your questions more easily, that would be really good. We'll get through as many questions as possible after Pete's presentation. As is usual with our webinars, we will be recording the session and putting it on YouTube for others to see afterwards. So if you don't want to be identified as participating, then probably best not to ask a question. And just worth me highlighting, Pete has very helpfully put QR codes on his presentation slides to his sources. So you can grab these with your camera on your phone as we go along, but Vicky will also share these links in the chat. So Pete, if I can hand over to you, if you've got your presentation ready.
Yeah, I will just share my screen. Thank you very much. Okay.
Brilliant.
Put it in present mode. Is that all showing okay?
Yep, that looks great. Thank you.
Excellent. Yeah, great. Well, thank you very much for the opportunity to speak to you this morning. I've been affiliated with the network sort of pretty much since the proposal stage, so and collaborate with lots of the folks involved in the network, but now it's growing. Of course, it'd be really good to get to know some more of you. As Jez said, I'm going to try to think about some of the win-wins and trade-offs in aiming for net zero in the agri-food system, for reasons that I think will become quite clear fairly soon, particularly focusing on climate change adaptation, which is the main area of work that I lead, and particularly focusing on the UK food system. Again, that's where a lot of the work I'm involved in is based. But I think the lessons here will also hopefully be useful and open up some interesting discussions for other regions of the world. And really this is just a bit of a starting point and to get some thinking going. So without further ado, I'll give a brief sort of introduction to where I'm coming from with this topic, talk a little bit about what we anticipate in terms of climate change for the UK and overseas internationally, given that we import nearly half the food we consume in the UK. That's important too. And then think about how climate change is likely to affect the UK agri-food system, coming particularly from the effects of the changing climate on the food system and the need to adapt and build resilience, and thinking about how that might overlap and interact with net zero and what some of the trade-offs and consequences might be. So really just to sort of start off, I also wanted to draw a bit of a distinction between the two key climate actions, if you like, that can be taken adaptation and mitigation. So what we're seeing on the slide here are projections of global temperature rises from the recent past across a range of different models. So this is why we've got the spread, and the average of the number of different models is the dark line. The spread is the colors there, getting lighter as you get towards the edge of the statistical distribution of models. On the left-hand side, we're looking at the global average temperature change from pre-industrial levels under a low emissions scenario. That's the blue. The red is a high emissions scenario. And the reason I'm showing these isn't particularly so much because of the levels of climate change, but because of the fact that when you look out to roughly sort of 2050, the next few decades, we see that the level of climate change, whether it's under a high emissions or a low emissions scenario, isn't really hugely different. So that does mean, at least under these scenarios, which don't include completely going to zero and removing emissions from the atmosphere from now on, but which do include some level of residual emissions, we see an ongoing level of warming until over the next few decades or so. So we will need to adapt to this level of warming. I'll just get the laser pointer out here. So, you know, in the next few decades, we're going to see some warming that we need to adapt to. On the other hand, if we look out towards the end of the century, there's a really big difference between low emissions and high emissions scenarios. And rather than 1.5, 2 degrees of warming under low emissions, we see something anything from sort of 2 to 6 degrees of global warming. So there's a really big difference, and this means two things to me. Firstly, that this particularly on this time scale, that's why it's important to mitigate and reduce greenhouse gas emissions, all the work the networks contributing to in net zero to avoid this extra warming here. But also there's another benefit in that actually, as well as avoiding that dangerous climate change, we'll have less to adapt to in the long term. So just to sort of draw a bit of a distinction, at least from my perspective here, and I hope that's useful. Why is it important to adapt to climate change as well as work towards net zero goals? At the bottom of the slide, you see some of the key reasons. So there are ongoing impacts, and I'll talk about a bit about some of these in the agri-food system, the things we're already experiencing, the changes in climate that are impacting our economy, the committed impacts. So as I mentioned earlier, we will still see some impacts even if emissions completely stop today. And an emblematic example of that really is sea level rise, which is in this figure here. These are different sea level rise trajectories from the recent past to the end of the century under a range of different emission scenarios. And because of the length of time and the inertia in the system connecting sea level to global temperatures, then there are really quite long-term commitments actually to ongoing levels of sea level rise that continue way beyond the end of the century. So we're committed to some level of impacts, but also we need to think about planning for the long-term and worst-case scenarios. And if we were to continue along business as usual high emission scenarios, what the outcomes might be in the long term. There are other examples of adaptation, not just to sea level rise through things like the Thames Barrier that's shown there underneath the figure, but flood protection, transport measures reinforcing the rail network in my part of the country. The reinforcement of the Dawlish part of the railway line was important in response to higher sea levels and storminess, measures in building and water management. And of course, we're going to talk a little bit about adaptation in the agri-food system shortly. My slides appear to be stuck. No, there we go. In terms of, let's just check that. Yes, they're still working. Okay, so in terms of climate change in the food system and particularly the impacts and adaptation, so I'm going to think of this in a number of different ways, but climate change itself will have direct impacts on the food system. And by this, I'm mainly thinking about the activities in the food system, all the way from farm to fork. And then the knock-on question is, seeing those impacts of changing weather patterns, what do we do about it? So this is very much the adaptation space, the actions we take, tools and solutions, but policy as well. But if we do things to maintain resilience in the food system, there will be consequences, some of them positive, some of them negative, trade-offs and feedbacks. And some of these will include net zero, both within the food system, but also outside the food system on things like ecosystems, broader societal impacts, and so on. And so that's really why I'm saying I'm going to focus mostly on adaptation and net zero and their interlinkages, because actually we could be here for rather a long time today. There are a great many number of different potential consequences, trade-offs and feedback. So hopefully this will just get some of the thinking going around this topic and open up some interesting discussions. So the next section, really, I'm going to think a little bit about how climate's projected to change in the future over the UK. And by the middle of the century or so, and out to the end of the century, we're looking at a sort of a headline message for, on average, hotter, drier summers and warmer, wetter winters, but coupled with an increase in the severity and frequency of extreme weather events such as very heavy rainfall, longer periods and more intense periods of drought, and higher summer temperatures in particular, and heat waves. As I mentioned earlier, though, it's also important to think about how this might, how these climate changes might unfold across the country, to give you a sense of how this might impact our farming systems and our agri-food systems. So the next couple of slides are just showing maps of projected climate change for a high emission scenario for the 2070s compared to the present day. The change here is for annual average temperature. In the UK climate projections that we have, we actually run a range of different climate models. So we can get an idea of the lower end of those projections, even with high emissions, and the higher end, and what the average change might be. So this gives you a sense of the spread. But under high emissions, we might be looking at sort of 6 degrees of warming in the south. And we tend to see more warming in the south of the country than into the north and in Scotland. And similarly, we can take a look for seasonal changes in rainfall patterns, here shown as a percent change in the precipitation in each season, in winter and summer, for the same high emissions and the 2070s compared to the present day. So as I said before, we're likely to see wetter winters, particularly with more wetting, with more rainfall in winter relatively over the north and the west of the country, and with more drying in the summer in the south and the east of the country as a whole. And I also mentioned a bit about thinking about climate change overseas, given that we import just under half the food we consume in the UK. So these are maps showing global average changes in climate at 2 degrees of global warming. So if we manage to hit a 2 degrees global warming target compared to the pre-industrial period, what would the patterns on the left-hand side here for temperature change look like, or for rainfall change? And we tend to see more warming in the north of the world, in the high latitude regions and over land, whilst the changes in rainfall, precipitation rates are quite varied across the globe. I'll just pick out a few here that might be important for the UK food system. So we see quite significant drying over the Mediterranean, North Africa, parts of Southern Africa and South America, all of which are regions that are both important to the UK in terms of importing things like fruit and vegetables, a key part of our diet, but are also in many cases quite vulnerable to weather and climate hazards, water shortages and so on in the present day. So I'm going to talk to you mostly about work, as Jez said, that we do as part of a programme of what we call a climate service for Defra that we've been running since 2015 around the broad area of food, farming and the natural environment. And just to emphasize, we do about half the work within the Met Office, and increasingly in recent years are doing lots more work in partnership with the likes of Rothamsted, with ADAS, and with Defra's genetic improvement networks, really to draw on the excellent research in agri-food that goes on in the UK. The goal of the work really is to support policy advice and policy evidence in support of Defra's goals. And what we're trying to do really is build on those UK climate projections as the cornerstone of the work that you see at the top there, that feed into our work, and really to assist Defra with their needs around agri-food in the UK's climate change adaptation policy cycle. And that consists of parts of the work plan really that are done by the Climate Change Committee's Adaptation Committee, so the independent review of risks to climate change and progress in adaptation that's done by the CCC, but also the official assessment reports and the National Adaptation Programme and associated reporting that's done by the government. And also important to note here, this is a cycle, so this process is done roughly every 5 years now, and also done in a cyclical manner is the UK Food Security Report, which is now done under Act of Parliament every 3 years, and is a bit like a state of the UK food system, looking at the trends and observations and issues in different aspects of the UK food system. So that's what we're trying to do with this programme of work. So what are the main impacts of climate change on the UK agri-food system? Well, I've taken this infographic from the Climate Change Committee's third climate change risk assessment, which was released a couple of years ago, which is part of that climate adaptation policy cycle I mentioned. And there are a few key points really I want to draw out from this infographic here. One is that there are both risks and opportunities, and also benefits of taking action in response to climate change in the food system. So it's not just about risks alone. The second is that there's quite a broad range of impacts of climate change across the UK food system, whether it be risks to soils from the changing climate and changing wetness and water patterns, whether it's sea level rise impacting aquifers and agricultural land, changing impacts of extreme events on the productivity of forests and agriculture, the risks that a changing climate might bring in terms of pests, pathogens, and non-native species, but also here opportunities for growing new species, for changes to landscape character, and for risks to food safety and security, both overseas and at home. And also building on the last few slides, looking at climate projections at home and overseas, opportunities to either import or export different foods in the UK as the climate changes in different ways at home and overseas. That will open up, if you like, and change the relative competitive advantage of growing and producing foods in different regions across the world and overseas. And the other points I just make are these colours, which represent these different, what we call risk identifiers. You'll notice that most of them, in terms of agri-food in the UK and in the risk assessment, are noted as more action needed. So that means in the next 5 years, we need to be doing more in practice, more policy, more action in industry, and or the orange colours, which are further investigation. So we need more scientific evidence to back up robust decision making in the next 5 years. There's relatively less in terms of continuing our current path or putting this more in terms of a watching brief for the longer term future. Okay, so one of the highest risk future shocks to the UK climate, to the UK food system, as noted by the Climate Change Committee, are changes in weather and climate extremes. And so because of this, over the last few years, I've brought together a partnership across UK government funders and the Met Office Academic Partnership, thinking about what the impacts of changing weather and climate extremes might mean right throughout the activities of the UK food chain. I won't go into this in too much detail. There is a paper that sets out the details here, but just to highlight really one example, if we think about heat waves and hot extremes, we can see that there are potentially impacts of future climate change in that sense, in terms of that hazard right throughout the food chain, whether it be the implications of high temperatures on heat stress of crops and animals and livestock or workforces outdoors, whether it's the need for increased cold chain transport, storage, and if you like, the middle of the food chain to make sure that food remains healthy and safe, whether it's the increasing variability in supplies through the food chain and to retail, but also at this end of the chain, retail and consumption, the changing demands from consumers for different food types in high summer temperatures. People tend to eat different things, more barbecue food, if you like, in general under high temperatures, and also impacts of high temperatures on the wastage of food, particularly where it's stored at room temperature. So what is the challenge in terms of climate adaptation in UK food security? Well, as I've just mentioned, that really the importance as perceived by the Climate Change Committee of extreme weather events to the UK food system, but at the same time, very new science from Lizzie Kendon at the Met Office, looking at future extreme events and in particular rainfall, is highlighting that in comparison to long-term temperature changes, we may well not see the evolution in future of extreme events as a smooth trend. We may well see clusters of new heavy rainfall records being broken in relatively short periods, and then seeing decades where we don't see any new records being broken. So there's significant volatility and unpredictability in future extreme events. And at the same time, as I mentioned, linking to the earlier slide, really, that the Climate Change Committee's report last year of adaptation progress highlighted that for the agri-food system, our plans, policies and implementation around building resilience in the food system are not where they need to be. And just one example of this to me that kind of brings it home were the millions of shed-housed chickens that died in the 2022 heat wave when we saw those record-breaking temperatures. So the kind of work that we're doing in the programme for Defra is basically trying to understand the impacts of climate change and also support effective adaptation in the UK agri-food system. And building on those UK climate projections, we're trying to make them more specific and useful and use the data for them to make them more usable and relevant to agri-food chain actors. And in this case, this is work that we've done alongside Defra's Genetic Improvements Network, the work that's done to bolster resilience and improve our crops within the UK. And this is, if you like, a tailoring of the climate projections to look at heat stress events around anthesis. So this is a key and sensitive period in crop growth and the crop development cycle, and only shown here over the arable and horticulture areas in the UK. In this case, it's looking at the number of years where this particular period between the middle of May, the middle of June, where we see daily temperatures exceeding 27 degrees C. You can choose other thresholds, but this is one we're using here. And what we can see is that compared to the present day, where this is a relatively rare threshold to exceed on an annual basis, as we move through, particularly to the 2050s, this is almost an every other year event or more. So quite significant changes in heat stress. So this is work we're doing with the genetic improvement networks to help them understand the kinds of traits we might need to breed into crops to maintain resilience in the future. But at the other end of the scale, we're also thinking globally, linking to the importance of overseas imports to the UK food system. And this is work alongside the University of Exeter and UCL, where what we've done is take a load of quite complex trade data and extreme weather indices across the world and look at country level to see how having a greater spread, a greater diversity of food sources geographically might impact any one nation's overall exposure to extreme weather events. So that's what the figure here really is showing, the diversity of sourcing against the relative shocks to food supply from a range of different climate hazards. And in a sort of a cartoon form, what the findings are basically that countries here, the blue colours, which are largely self-sufficient and don't import food, have quite a wide range of exposure to weather shocks looking at the recent past. So some of them are very resilient down at the bottom here, some of them are very exposed to weather shocks. What trade seems to do, and having a greater source of diversity globally, is it seems to tend towards more intermediate levels of exposure to weather shocks in the future. So this tends to underline to some extent the thinking that having a greater spread of sources might increase our resilience to supply shocks. But this is a relatively new study, and I think there's lots more to be done. Those are just a couple of examples of the work we've been doing with Defra to look at the impacts of climate change and some examples of the science. We've been working very closely with ADAS, and I'll show some more specific examples to think about what the effective adaptation measures in practice might be across UK farming systems and across a range of different weather and climate hazards. And what this figure here is trying to do is trying to rank some over 100, in fact, over 100 different adaptation measures in terms of their ease of implementation, how easy are they to do, but their overall impact, how effective they are. And then also to color code them in the text in terms of a qualitative measure of their upfront cost. And so what we're trying to do is say, well, actually, in this area here where things are easy to implement, have a relatively high impact and moderate or low cost, we're calling those quick wins. So those are things that we think we can implement relatively easily at low cost. So I'll just go through some of the examples of what those quick win measures might be in terms of adapting to heat stress and drought. So all farms can potentially improve water management, look at things like air conditioning, tractor cabs, bringing in fire breaks to avoid fire impacts in dry conditions. In cropping systems, think about earlier crop establishment, slower maturing varieties to avoid those very high temperatures later in the summer, irrigation and water measures, and thinking about how and when we harvest crops. And in terms of livestock, thinking around more diverse grass mixtures, deeper rooting species, and transporting animals at night, again during the summer, to avoid those high temperatures. And in terms of adapting to flooding and wet conditions, all farms can think about improving their containment of runoff and drainage, thinking about contingency plans for flooding, and thinking particularly about the resilience of power supplies. And in terms of livestock, a lot of this around working with vets and so on, and thinking about vaccination to diseases which can become more troublesome in wet conditions, but also planning grazing to make sure that there's spare grazing available in wet periods, and thinking about other measures like drainage around housing to avoid waterlogging. Crops, similarly, in crop systems, we can build up the soil organic matter levels and use more compost and green manures to help hold on to water. Okay, so that's a quick zoom through some of the science we've done and some of the thinking around adaptation in the UK agri-food system in response to climate extremes. But what might some of the co-benefits of taking climate actions be? I'm taking some examples here from an existing tool, which is provided by the University of Leeds, called the Climate Co-Benefits tool. And this in particular, this is just a snapshot for land, oceans and ecosystems. So this is all quite high level. But all I'm aiming to do here really is just to give you a sense that some of these interventions and actions can have different impacts. As I mentioned earlier, they might be economic, they might be over ecosystems in terms of energy health, or socio-cultural trade-offs and benefits. And this tool really is trying to set out whether they're positive, whether they're mixed, or whether there are risks associated with some of these co-benefits, how confident we are with the different kind of bullets here, and also some of the context and where these things contribute. I won't go into this in too much detail, but it's worth exploring if you're interested in this area. You can click down and get lots more text and information on these, and indeed there are more categories underneath these in the live tool. But just to illustrate, you know, in agri-food, in terms of some of the actions we might take, whether they're adaptation or mitigation, some of them will have largely positive co-benefits, but some of the implications are rather more mixed. So if you look at water management, for example, or nature-based and ecosystem-based adaptations. So to be a bit more specific, this table is taken from some of the work that we've been doing for Defra and with ADAS, and looking at broad categories of adaptation measures, and then trying to think across sectors how they might contribute to helping us build resilience to the different weather and climate shocks. But thinking at the end here, how they might interact with our net zero goals. And as you'll see here, some of them we might not know, or there might be rather mixed outcomes. Some of them might have positive implications, some of them might have negative implications. So I'll just take a few examples here. Water management could lead to negative net zero implications through increased water use. If we put in place more irrigation, it will require water for pumping, for example. Similarly, livestock housing, particularly where it requires air conditioning, will also likely incur energy use, and unless we're obtaining that from green sources, then that's a negative from a net zero perspective. Lots of different examples here, and I'll just delve quickly into a few more specific examples to give you a sense of some of the practicalities. So I'll just take a couple of examples: agroforestry and soil carbon. Of course, recognizing that these two are interlinked themselves, and thinking about the climate adaptation, net zero, and some of the other implications. So of course, agroforestry is good for net zero. We're storing carbon in soil and trees. It's good for climate adaptation and resilience. In heat waves, it will provide shade for animals. But we do need to think carefully about some of the other dimensions. Are we future-proofing species that we plant so that they're resilient to future climate change? And do we know what the overall water use might be of agroforestry systems, depending on some of those choices? Similarly, storing carbon in soil, of course, is good for net zero goals. It's probably also good for climate adaptation. We're likely to store more water in soils and bolster our resilience both to dry and wet conditions. And it's also likely to improve productivity and the soil ecosystem overall. But we do also need to think about the impacts that climate change itself is likely to have on soil processes. Warming, for example, tends to accelerate soil organic matter breakdown. So I'll give a live example now, really, just before rounding off with some recent areas of work and some conclusions. So the 2022 heat wave was particularly interesting, I think, from a climate perspective and from a net zero and adaptation perspective. As I mentioned earlier in the talk, it had significant impacts on poultry. Meat production was down compared to the year before. There were increased energy costs in production and refrigeration failures. These green dots overlaid over a map of temperatures at the peak of the heat wave on the 19th of July. So particularly where the intensity of the heat wave was highest, we saw these failures in supermarkets. What can we do to adapt in poultry? Well, things like more heat tolerant breeds, changing the stocking density, nutritional supplements, some of them which will probably have relatively limited implications for net zero, but others, as I mentioned earlier, air conditioning measures and climate control measures in housing are likely to have energy consumption implications, and similarly, for better or for worse, whatever we do to improve refrigeration resilience and efficiency may well have implications for energy use. In contrast, wheat was an interesting case study in 2022, largely because the crop was well established early in the season and to some extent avoided the peak of the heat wave. We actually saw yields being higher than the 5-year average preceding it, but we did see smaller yields in the south and the east where the impacts of the heat during the year, which were not just during that July period too, but were felt most strongly. So adaptation, as I've mentioned earlier, might be earlier maturing, more heat drought tolerant species, earlier sowing, but some of the measures such as irrigation and soil, water and conservation measures are going to have implications for net zero, some positive, some negative. So building on all of this, really over the last year or so, we've been trying to build community and a broader understanding of some of these issues, both through some big online interdisciplinary workshops that we held back in January across academia, industry, policy and beyond. Some of the key issues we drew out in the January workshops were again around the cold chain and cold storage and the knock-on trade-offs for carbon and energy use. Of the relative pros and cons, if you like, the balance between local and international food systems. And in local food systems, whilst there's a positive impact for the local economy, you might be concentrating your climate risk if a local region kept getting hit by floods or droughts systematically. But on the other hand, pushing towards a more international food system might open up different food safety risks from different production regions and practices. Lots around waste and lots too around the costs of resilience. So a heat resilient crop is likely to perform better during extreme heat waves, but probably not as well as a crop that's tuned to perform well under average conditions. So there will be trade-offs. Similarly, there are some really nice webinars for different audiences around resilience and adaptation that ADAS led with our participation at the Met Office, and you can look at all of these too on YouTube. So very finally, there are risks and opportunities for UK food security, both domestic and overseas. We do need to be thinking about the whole chain and systems approaches, thinking about adaptation, resilience, net zero, and the broader consequences altogether. Really critically, though, from my side, I think in response to the Climate Change Committee's noted lack of action and importance in this area, it's about working together to support adoption and implementation in farming and the wider industry. Lots of effective dialogue and co-design needed. So thank you very much, and I look forward to hopefully some interesting questions and discussions.
Brilliant. Thanks, Pete. If you can stop sharing your screen and then we'll open up the floor to questions. That was really interesting. Thank you so much. Lots of great graphs and data and everything, and some quite shocking data, I suppose, as well for mid-century. We've got loads of questions. I'm going to pick up to start with one from Anne Owen. So Anne says, all these adaptation measures will carry a cost. Who will bear this? And is there a recognition that within our current economic system, these measures might not be considered cost effective? And I would sort of add to that, I guess, that a lot of what you've been talking about, it sounds like it really needs some sort of big strategic oversight, doesn't it? And I sort of wonder how much of these adaptations that you're sort of talking about on farm that farmers might be able to do will actually be able to make a difference unless there is a wider government sort of strategy that sort of goes across, that recognises the burden of that cost and also understands that this needs some kind of strategy behind it.
Yeah, so two things. First of all, on this first one, I'll say I'm by no means an expert on these, but it is my understanding that the work we're doing and other thinking, of course, in the UK community is feeding into some of the thinking in things like the Sustainable Farming Initiative and the ELMS programme, and that largely climate resilience should be being built in and thought of around those measures. Now, what I'll say is I don't know how that's actually happening personally, and kind of what the details are. To me, that seems a very sensible approach, because kind of partly the argument of today's talk is actually there are lots of things we need to think, about in changing things in the agri-food system. So it makes sense that things are included within those broader measures. But I think it will be important to see how that's done specifically. The other thing I think is important, or an important piece of work, we've started this work with ADAS to think about, in really qualitative terms, what is cost effective, what might work well. There are two sides to that. One is we do also need to think about some of the things that might be harder to do, but might cost a lot, but might still be really important. So if we look further ahead and something might be costly and important to put in place, I don't think we want this just to, but we need to make sure the support's in place. So we don't want this just to be about cheap, quick things either. But equally, the points I made about climate volatility, if you like, and particularly around extremes, I think we're going to need to try and find a way to provide evidence that helps assess what we expect in the coming decades in terms of the evolution of extremes. A typical question, we had some discussions, for example, with ASDA around the work we did on the 2022 heat wave. When should I build a more heat resilient chicken shed? How many years out of the next 10 are we likely to see those temperatures? Those sorts of questions. And at the moment, I don't think we have yet got the robust and the detailed information to do that. But there's two sides. I think the science needs to do that, but we also need to work with industry to understand the nature of the questions and come up with more effective solutions. So that will hopefully help with understanding some of the economics of it. And hopefully the bit I said earlier points in some of the right direction around policy and support. But I completely agree. We kind of need to understand both of these dimensions.
Yeah, thank you. I suppose just picking up on that, like you said, your chat with ASDA, and the sort of, I guess, the opportunities, the business opportunities as well that are there, and sort of knowing what might be sort of coming. I've got a question here from Lawrence Pipitone. How significant are the opportunities of climate warming for opportunities with diversifying into new crops that were maybe not suitable before? There's a lot of talk about that, isn't there? But to what extent is that going to be a real opportunity?
It's a really good question. So I think, if you like, from the sort of the biological and physical side, I think there probably is quite significant potential there. There's some really nice work that's been done for a recent government project around sort of net zero targets that CEH have done, looking at, they've got a really nice tool that I think it builds on FAO data, but it looks at the suitability for a whole load of different crops and then mapping on the climate change on top of that. So I think, in terms of scientifically, I think there's probably lots of promise there. I think the bigger issue is probably the adoption and the demand for that in the food chain, and actually people sort of wanting and needing those crops and the shift there, So I guess, you might say one implication of future climate change, might be if we see more risks to future wheat and we haven't bred in resilience, we might see lower quality wheat being produced, which wouldn't support the kind of bread that we're growing now. Would people accept, rather than a standard loaf, flatbreads, and which might be produced with other or more more alternative crops and things? I don't know, and it's those sorts of questions that need working through. There are some nice studies being done around some of these areas, but I'm not sure there's in-depth thinking about it yet.
I guess sort of picking up then on what you're saying, that part of that is a change in diet, isn't it, and what we're used to. I've got a question from Becky Late from Fix Our Food at the University of York, saying, and there's another one from somebody else, from Roberto Rivera as well, about this. So Becky says, considering its benefits to reaching net zero and other health and climate goals, where do livestock reduction strategies fit into these other climate adaptations?
That's it's an interesting question. So, I mean, I haven't shown, just because of time and things, that much of the work we've done on livestock. There is the work I showed compared to that was looking at heat stress in crop, in crop anthesis. We've done similar work looking at heat stress for different types of animals and so on, and we do see quite significant increases for most livestock types into the future. It's a really good question. I don't, from the side of the work that we're doing in this particular program of work for Defra, it's not really one we're yet tackling and moving into. But I think in the context of these wider discussions with the network here and so on, I think some of these, again, it links back to the earlier point I made that this is about systemic change, and some of this stuff needs, to think, yes, very much about production, which is critically important, but also kind of what that means through the food chain. I'd probably also point out, there's some really exciting research I'm aware of, some done by the University of Oxford, sort of almost on the implications end of that, which is looking at things like growing different varieties of UK grown beans that could be substituted into alternative forms of protein, things like baked beans and so on. And there's quite a lot of that, going on elsewhere. So I think, all of this stuff kind of needs to be coupled together, but it does somewhat link to the earlier questions too about the sort of the changing opportunities and the overall nature of the food system, I think, in the UK.
I've got a question from Clive Mitchell from Nature Scott. He's saying, could you say more about a more chaotic climate in Europe? The idea you were talking earlier about clusters of extremes. And he said, and so they need to spread bets, for example, multiple crops yields rather than monocultures. And he said, does this point to more regenerative practices as well?
I think that's a really good question, actually. So I think, ultimately, if in an ideal world, if we could provide seasonal forecasts that were super accurate and could support, someone say, actually, I know for the coming season that it's likely to be completely average, or that it's going to be really dry, or that it's going to be really wet, then they could make a really concrete decision on what to do for their crops or livestock moving forward in that year. But the reality is that on those sorts of time ranges, UK climate's quite unpredictable. The seasonal forecasts we do have are generally most skillful in the wintertime. But having said all of that, I think it still points towards some exactly, as you're saying, some thinking about sort of spreading and balancing risks. So, if there's some uncertainty, or you think there's a chance of droughty conditions, then you could potentially plant half drought resilient crops, or half of an alternative crop that's more resilient and half of the normal ones. Those sort of things, and sort of hedging and risk spreading, I think, are quite important. But a personal view is, I do think, increasingly some of those ways of doing things, the more regenerative, the more being able to sort of diversify the systems, I think, is quite important, whilst recognizing the need. We do have a growing population, and currently demands for food are continuing to grow, so we will need to make sure that those systems can produce enough food as well into the future. But maybe the climate resilience side of that is an important part of the story.
You were talking earlier, Pete, about the significant drying that's likely to happen in North Africa and the Mediterranean, and how reliant we are as a country on those. But then, for fresh fruit and veg. But then you also shared, there was a graph you had showing results of a study into, I guess, how vulnerable or not countries are when they're self-sufficient.
Yeah.
So I just sort of wondered about that. I mean, I know you said that research is quite early, but is there likely to be a sort of sweet spot, as it were, in terms of how self-sufficient we should be as a country, but also how much we should be spreading spreading our risk amongst imports, and where do we know where the UK sits currently with that?
So my understanding is that sort of currently at policy level, I think there is general support for having some spreading of of the risks, and largely kind of, I don't think that, well, my understanding is there's not a massive drive to push it particularly hard one way or the other, but I do think there is a recognised need to increase the resilience, particularly of our food systems within the UK. I think that may be harder to do internationally. Could we build into trade agreements or supply agreements some requirement based on resilience and making sure that people are well resilient and adapted? I suspect that probably might come, and there are other drivers that might push things that way. One thing I will say on that piece of science, I mean, it's the reason I was a little bit tentative with the conclusions is one thing we have discovered in bringing together those data sets. I think there are questions about quite what we can say with them. So I think there could be improvements in the data, and so actually we've put out we're advertising at the moment for a PhD project to look at hopefully making some better data sets around this area into the future. But yeah, it's really critical to understand, and actually I think this is looking at, so the work I showed was looking at the recent past, the last 30 years or so, 20-30 years, but it's also really critical to try and build on that to think about the future and how things might change.
Following on with the idea of risk like that, there's one here question from John McKay. Is the concept of local production and consumption and so shorter supply chains, I'm just going to paraphrase it, is it a worthwhile goal in the light of the need for diversified supply chain to reduce risk? I guess to what value do local supply chains and local food production have in this context when we're talking about risk and resilience and everything?
Yeah, so the one around resilience and risk, so I think potentially, yes, in terms of food quality, in terms of local economy, yes, in terms of reducing emissions, yes, and I think ultimately too, from sort of citizen buy-in and an engagement in food, I think that's also really key. The one that we do is a bit of an unknown is, if we overly localize food systems and we become really resilient on a local area, that could be nationally or it could be domestic, within a county or a whatever, a local region. If for whatever reason that area keeps getting hit by floods or heat waves or something, then there's increased vulnerability. So I'm slightly playing to the theory of the last question, but the honest answer is I don't think we really know until we do a bit more of a detailed study on that side of things, quite how that might play out.
Okay, and I've got a question here from Dominic Waters, who was our last presenter in December. Said, will this disproportionately impact poor families in terms of food insecurity? And I'm guessing by that Dominic's meaning in terms of the climate risks and shocks and the impact of that on the food system, but also I guess the adaptation measures, and is all of this going to increase costs through the supply chain to the consumer?
I don't think, so at the level of sort of detail of the UK and some of those detail adaptation measures, I don't think we really know. But I think from the broad brush science, sort of the global and national level science, and also sort of scenario type work done by the likes of Tim Benton at Chatham House and others, I think when we think about climate resilience, the need for broader sustainability in the food chain and net zero, and working towards sort of the Paris Agreement in the food system, I think no matter sort of which pathway you go down, I think higher food prices largely are anticipated. And I do think that is something that needs to be taken very seriously, particularly given the levels of food poverty that we do see here in the UK.
Yeah, very important topic. I'm also wondering, and there's a few around this as well. Also wondering about the regionalisation of food, because on some of your maps, you know, I mean, the south, oh my gosh, south of the UK, not looking like it's going to be great. Southeast, you know, and there's actually our sort of breadbasket, isn't it? I mean, I'm sat in Norfolk and thinking, oh my goodness. So what might need to happen in terms of our specialization? Because at the moment we're very regionalized, aren't we, in terms of our specializations of food production? How
Yeah.
might that sort of shift or need to shift?
Um, I think there are some really big challenges there. There was some work a few years ago by the University of Exeter using some detailed and more at the extreme high emissions end scenarios towards the end of the century that's, I think, sort of brought together the climate projections and some agroeconomic modelling. And broadly speaking, you know, because of those summer water shortages in the east of England, it was pointing towards decreased viability of arable cropping systems in the east, and sort of, you know, almost hinting at sort of some fairly big shifts in cropping system distribution. But of course, you know, there are some immense practicalities there, that most of the land in the west of the country is grassland or pasture for good reasons, and it's, you know, it's all around, you know, the broad scale sort of suitability of the land. So I think the other thing I'd say, you know, even we tend to see, so probably largely wheat's likely to benefit from at least some warming in the UK. We're quite a cool climate, but as it gets more extreme, that it might not be so favourable. And, you know, in a geographic sense, I think further north and into Scotland, we're likely to see sort of gains for most cereal crops. Some of the challenges, though, if you shift some of these zones significantly, as I understand it, some of the key infrastructure like mills and maltings and so on are very tied to, you know, and critically linked to local areas. And so there's another sort of viability question as to whether it's economic to have them suddenly, you know, somewhere much further south if you shift everything north. So I think there are some big questions for the long-term climate, for sure.
Yeah, some huge infrastructure sort of issues there for sure, and skills based, I would have thought as well. Quite a different question here from John Harold, who says, "Have you looked at the climate, at how the climate impacts and resulting agricultural change, so the adaptation, will impact on habitats, for example, semi-natural grasslands, heathlands, and wetlands?"
Not yet, no. And I think, you know, it's a really good example of how, you know, of the breadth of what some of the trade-offs and implications might be. I mean, I think there's quite an urgent need to think about some of those things in a joined up way, but no, not in detail to my knowledge. I mean, I think it's probably worth saying this, and I'm not saying this just because it's sort of the area of research I'm involved in, but I think there's been a lot more action, and to a degree science, around the sort of the net zero and the carbon storage in agri-food systems, and which is also really important, because if we don't do those things soon, those, you know, they take a long time to put in place and to have an effect on the climate. So it's, you know, but at the same time, I think, you know, we're sort of, that more needs to be done in terms of understanding not just the potential for adaptation, but some of the consequences. And hopefully, you know, that's something which academia can really help us with, and some of the research institutes.
Yeah, absolutely. Well, it's 11 o'clock, so we're going to have to leave it there. But Pete, thank you ever so much for all your insights, your presentation, all your answering of questions, and to everybody else for participating and engaging so much. I think this has been our most well-attended webinar yet. So you're
Wow.
beating the likes of Henry Dimbleby and people, Pete. So
Right.
great.
I'm
So
very flattered.
yeah. So thank you ever so much. And yeah, thank you again, everybody. We've got so many questions. There's a really long chat. We will save both the questions and the chat, and we'll be turning this into a short briefing at some point as well. So hopefully there'll be lots in there. I think, Vicky, if you could share the links again in the chat that we shared earlier, there's lots of links there to Pete's sources of information and everything. So thank you very, very much. So our next webinar, we're still planning at the moment, but we're hoping it's going to be on the 8th of February, and that we're going to be looking at the UK's reliance on fresh food and vegetables from climate-stressed regions. A very good follow-up to today. And what we might need to do in terms of domestic production. So Pete, I think I'll be contacting you a bit more information on your study about all of that.
Sure.
So look out for further information on tickets via our email listing, social media, and our website. You can also browse our back catalogue of webinars, which goes back a year now almost, on YouTube if you've missed any previously. And finally, we welcome any comments or suggestions for speakers or podcast interviewees you'd like to have in the series. So please email either myself or Neil, who's a co-lead on the project. And you should be able to have our email addresses in the chat where Vicky's just shared. So thanks all again, everybody, and we'll see you soon.